Problem number 23. It says let p and q be positive integers such that we have this equation, determine the smallest value of p. Again and again, we want to use considering a small example, which I mentioned that in my video, in my channel, exactly 2 days before the exam. I said what? I said Lagrange multiplier, and I said it's useful to use that in the exam. And in open section senior, you should use that, and you could solve many problems with considering a small example. Problem number 21, hard problems of this exam. So here we have what? This expression, it says find the smallest value of p. Okay, so we can say, because we can factor from p, let's factorize 5p minus 18. Right side is q to the power of 8 minus 7. So here, we know right side is positive, so also left side should be positive. Now, if we want to, left side is positive, so you can say it is increasing. So if you want to find minimum of p, it is equivalent to find minimum of q, exactly like problem 21. For finding minimum x, we've tried to find minimum y, and x minus y, for example, was greater than 5. If you see my solution for problem number 21. So here, we try to check some example to understand problem is what. So at first, let's try when q equals 2. So p times p squared minus 5p minus 18 equal 2 times 28 minus 7. It is what? 28 is 256. And it will be 256 minus 7, which will be 249. And we can factorize 2 times 3 times 80. 383 is prime. Now, here, p can be only what numbers? 2, 3, 83. 2 is impossible because this one will be negative. 3, 9 minus 15, again it will be negative. Also, if you place 83, then you can say, okay, it is 83, factor from 83, 83 minus 578 minus 18. It is so much greater than 6. So Q2 contradiction. Let's check Q3. Also, I released some problems of IMO international level in my channel. Also for 2021-2020, you could solve them completely with considering small examples. So let's solve the next case. P times p squared minus 5p minus 18 equal to 3 times 3 to the power of 8 minus 7. Now, if we calculate that, 3 to the power of 8, 3 to the power of 6 is 7 to 9. It will be times 9. So it will be 9, 9, 81. 9 times 2, 18. 16, 26. And then we have 9 times 7, 63. And it will be 61 minus 7. It will be 3 times 11 minus this 4, 5, 5, 6. If we prime factorize this number, it will be 3 times this one. It will be 2 times 29 times 113. Okay, now we want to find what p is good. P can be only, let me write possible cases. P can only be 2, 3, 29, 113. If you place 2 and 3, it's obvious here it will be negative. For 113 here, it will be a large number greater than this like previous time. So we will check 29. So here it will be what? 29 times 29 squared is 841 minus 5 times 29. It will be 45. We have 4, 145. 145 minus 18. Okay, here if we add, it will be minus 361. If we subtract 11 minus 3, 8. It will be 3, 13 minus 6, 7. And 7 minus 1, 6. So if we factorize this number, it will be 2 times 3, 3, 9. And it will be, if I continue, it will be 2 times 3 times 113 exactly here. So it works. We found for Q3 P equal to 29, and it is the minimum answer because we said if you increase Q, P should also will be increased, and we can say the minimum answer here is 29. So again, we've solved this problem with considering a small example. You can solve so much harder problems with that idea, like IMO problems, and you can see them on my video. And exactly 2 days before exam, I told you this idea is so much useful. Again, I will release useful and important ideas for next rounds and other Olympiads. You can use them. And so please don't forget to subscribe and turn on notification for having next ideas.